Good morning, everyone. I'm Paul Coggin from Alabama in the U.S. I work for a aerospace company in the U.S. called Dynetics. I'm a network security architect where I specialize in building, designing, securing, and figuring out how to break into telcos, SCADA, critical infrastructure networks. I run around the world doing consulting in this area and speaking on security issues in these domains. And what I got to share with you this morning is some real-world stories that I've seen with critical infrastructure of how things are being broke into and how we can possibly fix some of this stuff. So I come up with this talk, Digital Energy BPT, and BPT is basically the basic persistent threat. Now, after I developed this presentation and gave it the first time, I realized I should have named it VPT for Vendor Persistent Threat, because one of the common threads that we'll see as we go through this presentation is a lot of the problems that I'm calling out are being built into these networks by the vendors. Things with default settings, backdoors that bypass firewalls, VPNs that are enabling old school attacks that we should have been past a long time ago, or enabling adversaries to get into our critical infrastructure. And when I talk about critical infrastructure, these are the type of networks that I see around the world where the public network infrastructure, whether it's the telco or your utility, it's all converging. Your cable company, your telco, the utilities, the power grid, it's all converging into one network infrastructure. The cable guys are even getting into the power in some places. The telcos are getting into SCADA, smart grid. The utilities are getting into the telephone, cable, IPTV business. And this is kind of like the high-level network architecture. At the very top, what you see is the services we call OSS, Operational Support Systems, and in some cases it may be BSS, Business Support Systems, and that is where your main server head-end operations are, where all the intelligence in the network is, where you're going to have your SCADA, you're going to have your network management, your provisioning, your automation, your billing system, back office integration. And then you work your way down into the network. You have your core network infrastructure, your transport network, as we would call it. It might be dark fiber. You might have your fiber lit up with SONET, SDH. Over here in Europe, it'd be SDH. MPLS, possibly a transport backbone you might be using. And then you go down into the network where you may be running passive optical, fiber to the home, active Ethernet, all the way out to where, in the case of some of the utilities, are running out wherever they have a meter, wherever they put out a new smart grid meter, they may be rolling out these services too. And then you have your legacy SDH, T1, E1, depending on what part of the world you're in, technologies. But the common thread from the top to bottom is the trust relationships. You have a trust relationship from top to bottom between all the different systems. All of these different components are being installed by different vendors into these traditional critical infrastructure networks. And in many cases, the network guys that are running these networks, say like at a utility that's getting into the cable ISP business, they don't know IP very well. Or you may have a telco that's getting into providing smart grid services to the utilities. They're really not educated on SCADA type networks. And so what happens is the vendors go and drop all this new complex technologies in wherever it is in these layers that I show, and they're going to build into their RFP, their proposals, that they're going to have remote access, because they understand when they drop off the Ryder truck with all this new technology, the network guys are not going to know how to run it, and they got to keep their customer sat up, so they're going to make sure they got back doors and ways to get into these networks to help manage it. The problem is there's not definition in how these networks are going to be managed remotely, and I'm seeing that these networks are being easily popped via these backdoor connections, and I'm going to give you some real-world examples. So SCADA, the diagram on the right hand, that's the ISA 99 standard for how a SCADA network should be architected. Could be an ICS network, an industrial control system network that might be in a chemical plant, manufacturing. What I typically deal with is in the utility industry, where it's SCADA, where we're managing the substations, possibly water, sewer. And so at the top you have your enterprise network where you would hope to have a firewall that segments off the SCADA network where your engineers would be working. And then as you go down into the network, you get further down into the layers where there's actual physics being controlled, where on one side there's an IP or some legacy protocol network that is going to send signals to a device that is going to make something in the physics domain happen, turning relays on and off, turning power off and on, et cetera. But what we actually see in reality is up there at the top where you see the firewall between the enterprise network and the SCADA network. In many cases, what you see real world is that segmentation is nothing more than a Windows box multi-homed. And in many real cases, that segmentation, if it has a firewall, the firewall has got so many holes punched in it that it's basically acting as a router. When you go in and do an audit of, you start looking at the configs, there's so many ACLs that have been conduits that have been opened up into that firewall that it's basically just acting nothing more than a router. And in an actual real world scenario, I did an audit. I found a firewall where it was so opened up, literally, can't make this up, permit any, both in and out. And the vendor put that in for them. That was on the firewall to the business network that I actually saw this. And they had what you would think with a lot of the stereotype we have in our minds with SCADA networks. They had a separate network for the SCADA network from the business network. So the firewall for the business network was permit any, both in and out. And so after I saw that, I freaked out and I asked this particular SCADA, this utility that was running SCADA, I was like, show me your SCADA network. How do you get into it? And faster than my eyes could keep up with, the gentleman whipped out his Android phone and VNC'd straight into his SCADA off his Android phone, and never once did he put in a password. Again, vendor put that in for him because, and the guys love it because they can, they can be anywhere and remotely manage the SCADA network. So here's a real world example of a voice network where these networks are being deployed. They'll get into rollout soft switch. In your enterprise networks, you may have Avaya, you might have the Cisco Unified Call Manager system. I'm used to deal with the Cisco Call Manager in my day. Some people have the Avaya. But in the telco world, what they call this is a class 5 switch. It's a soft switch that is big enough to run voice over IP for a large geographic area, support tens, hundreds of thousands of people. And it's basically some souped up servers that you can consolidate what would take, fill up a half a room this size. You can consolidate it down to about a half a rack. And when they put that in, what I've seen in some cases, to ensure remote access, they're basically the vendors, this common thread, the vendors will go in and put in a backdoor connection, typically SSH, it's secure because it's SSH, right? But the attack surface that they opened up is that anyone that can find that SSH service can sit there and do a brute force dictionary attack against it until they get a connection. They don't have the trust relationship locked down to that only their home network, the vendor's corporate network, can VPN and connect into that network. They have it opened up so that anywhere in the world, anybody that can find it can go and attack their network management system, totally bypassing the firewall VPN architecture that might be in place to enable ease of remote access. And what we've seen many times is these networks are being found, SSH brute force, and the only way that the critical infrastructure vendors are finding out is when they get notified by some bank, say in Europe, where their critical infrastructure is being used to attack a bank, and then they get a cease and desist letter from a third-party organization. Hey, your stuff is being used to hack me. Stop it now. So along the lines of the transport infrastructure, when I was going through school and learning networking, both in undergrad, grad school, and taking certification courses, I learned about rings in the telecommunications industry. And before I got into becoming a telco service provider engineer, I thought a ring was a geographic ring, that there would be physical diversity in the telco ring topology that they were selling. That's what I was led to believe. I got into the cloud and actually started working as a service provider engineer. And I discovered there's this concept called a collapsed backbone that I show at the top, where instead of a physical geographic ring like I show at the bottom, where you may have networks tied together via different cities in a diverse topology, what they actually may do is pull a single fiber down, say down a major highway or along the poles, maybe underground, and then on both ends of the fiber, loop back out and logically, electronically create a ring through one fiber sheath. So what happens with that is, in the U.S., I don't know about here over in Europe if y'all have it, but one squirrel, raccoon, drunk driver, backhoe. I don't know if you guys have tornadoes over here. I'm from the South in the U.S. We have a lot of tornadoes. One tornado could wipe out your network connection, but you bought a ring. You bought a ring topology. But one connection, and actually I saw one telco service provider experience where some gentlemen decided they were going to get into the copper business and climb the telephone poles and started thinking they were going to cut the copper off the poles, and what they ended up cutting was fiber and knocked out the communications between two cities. So here's an example. Had a telco got into the business of providing IPTV, voice over IP, cable TV over IP, where your TV channels are mapped to IP multicast addresses, so you're changing multicast addresses every time you hit the clicker on your TV. And they also got into the business of providing smart grid services to utilities. And they brought us into a security assessment to test the posture of the network. What we discovered in this case is the vendor for the billing system put in a firewall for them. Great, put in a firewall. But what we also discovered during the pen test is that the vendor did not put in any kind of external DMZ architecture in this critical infrastructure network where they're providing numerous services to this community. So that the architecture is that the internal billing system and the external billing system are all sitting on one server. So all you have to do, and then what we discovered in our pen test is pop a JBoss shell, get a shell on the server, and from that be able to spread influence across the network. And because there was no segmentation, and there's an inherent trust relationship from the billing system to the infrastructure up in the upper right-hand corner, where you have automatic provisioning, and where the network can be from the billing system all the way down to the customer endpoint device, automated provisioning, where you pay your bill, your service stays on. You don't pay your bill, your service is automatically turned off. There's no truck roll. Or if you want new services, it could be automatic provision. Well, there's that trust relationship between that billing system and that network infrastructure that could be easily exploited once that initial handhold was grabbed. And we ended up having lots of screenshots showing shells, how we were able to do this, and we stopped because of rules of engagement. Didn't get to go as far as we wanted to. Laid this all out in the vendor who put in the billing system. They won the argument. This architecture gets to stay in place, and we don't do security assessments anymore. But the thing I learned there as a security person, as a technical guy, is whoever is involved with the financials, that can talk the language of the CFO and the CEO, which is numbers, they're going to win the argument no matter how strong the technical argument is in many cases. Because these guys helped, they did the billing system, and they controlled how bills get paid and how revenue is dealt with. So they had greater influence at the table. It's really sad. And that billing system vendor now is in the security business, if that makes you feel any better. I hope nobody's using it. Again, VPT, vendor persistent threat, they paid for this. So here's an example of a transport network where you have the voice, video, internet, smart grid, all the telecommunications services you can imagine, SCADA, everything runs across this. Managing smart meters, wherever there's meters deployed, all runs across this infrastructure. And in the center there, we have a transport network where we're aggregating fiber, maybe multiplexing light frequencies out to lambdas to run different services all across this core network. And what's key to note with this core transport network is this particular vendor that was put in, they implemented some technology in their ASICs because they knew that their customers are implementing IPTV, where they're, like I mentioned earlier, where they're multicasting cable TV channels over IP. They built into their ASICs so that the multicast, the IGMP handshake that happens typically at layer 2, instead of that having to go through the normal RFC process, they just did it in ASICs so that it automatically happens. Any traffic that gets put into this particular VLAN on this transport backbone would automatically be replicated in ASICs. And that's really good because it gave a really good fast performance in response time. If you're a customer and you're changing channels at home, you get a really quick response, really crisp TV channel changing response. Problem was, because they broke those RFCs and did that in hardware, there's no internal threat, right? Insiders have no issues. In this case, it was an accident. The supervisor accidentally provisioned internet traffic over into this VLAN, into the core transport network for cable TV IP video. And as a result, when they provisioned a large segment of internet traffic, internet subscribers that are infected, with all the internet botulism of botnet malware traffic, they put that over into that video VLAN. The hardware automatically started replicating that, and the network rolled over. And when I talk about rolled over, all these services over here on the left-hand side, smart meter, SCADA, voice, video, internet, all of that rolled over. No core transport, no services. They started looking at, luckily in this case, they made a good investment in secure visualization and instrumentation so that they had visibility on the problems. And we were able to, I was actually on the highway and had to pull over to the side of the road and dissect packets over the phone. And as they were explaining to me, we figured out what had happened is we started seeing all this denial of services traffic encapsulated in IGMP. That was some crazy stuff. ICMP, denial of service traffic, inside of an IGMP packet. That was really weird. But key takeaway is with this network infrastructure, if you're involved in this domain, you've got to have some tools in place so that you can do full peak, not only go and get a net flow, see who's talking to who, when the session started, and how much traffic is flowing between the devices, but be able to do a full peak cap and be able to do it in large quantities, at 10 gig or more, so you can troubleshoot something like this. So here's a problem that we saw it a couple years ago, and then it just recently happened in Brazil to like 4 million modems. And the key point here is both in the networks that I saw and the network in Brazil, the telco that got hacked. And we see this around the world, is a lack of attention to separation of the control plane, the data plane, and the management plane services. Control plane being the network protocols, your router protocols. So your OSPF, your EIGRP, your BGP, having that locked down. And then the management plane, how the devices are managed, having that locked down and secured. And then your data plane. And in this case, the core infrastructure of this network was locked down, but the DSL broadband network devices, the CPE that the telcos are putting out at the endpoints was not secured. And what happened when we first discovered this hack is we had two telcos that got hit. One telco, they discovered it at 600 routers. They were able to stop it because they had tools in place to detect it. And someone in another part of the world started running tools to hack all of the DSL routers. They knew about a backdoor username password and started getting these routers and changing the DNS settings. So when a user plugged in and they booted up and they got DHCP, the DNS that they got would redirect them to a rogue DNS server somewhere out in the internet. So one telco was able to stop it at 600. The other one, about 6,000 routers before they stopped it. And this same attack happened over in Brazil, and it was like over 4 million routers before they got it stopped. And all that had to happen is the management plane being secured so that no one that wasn't authorized could touch the DSL CPE. And along the lines of the control plane, managed plane, data plane, separation of service, here's another example. Had a telco They needed to bring up a temporary ATM circuit. Believe it or not, we still have to use ATM every now and then. Every time you think the ATM is dead, it pops its head back up. So we had to bring up an ATM circuit temporarily to get over a bandwidth crunch until some new fiber could get provisioned. And so what ended up happening is the telco pulled out an old router that had been mothballed, had running old code, and didn't realize, but in the access network, they had not secured the control plane at the access network to stop internet subscribers from being able to interact with control plane protocols, with network protocols. And what I mean by that is they had this old legacy router put in place as that temporary stopgap, and one of their internet subscribers started trying to initiate BGP connections with their core network infrastructure. Why in the world would an internet subscriber on a low bandwidth connection be trying to initiate BGP connections with your core BGP router? That should have been stopped cold at the access layer. But somebody found interest in it and started sending malformed BGP packets and rolled over their router. And it could have been simply stopped with control plane protocol security. So this is when I first got really aware of the vendor persistent threat issue. A lot of these cable TV networks that are being put in, the new IPTV head-ins, in the utility world they call a data center, or in the cable TV world they call a data center a head-in. It's all about marketing who you're talking to. If you're talking to a CEO, they call it a central office. Well, in the cable TV world, they call it a head-in. So in this head-in, you have analog digital converters, you have middleware to talk to the analog digital cable TV devices and integrate with your billing system. There's a whole lot of integration that's happening. Lots of different vendors providing different parts of the solution to provide these new services. And in this particular case, I was doing some network infrastructure work one day, and one of the head-in vendors showed up out of nowhere, unannounced, unplanned, with a new server, a free, unannounced upgrade. How many times does a vendor show up with a new free upgrade for you, including hardware? And so it got me a little curious that they showed up to roll in this new hardware while I was there. And the customer, these guys are used to, this driving a bucket truck. Before they got into the cable TV business, they were out, provisioning power, troubleshooting problems with the electric grid. So being a customer advocate, I started digging into the problem, and what I discovered is that the vendor had gotten hacked. And when the vendor got hacked at their headquarters network, they had a trust relationship into the cable TV head end, and the adversary pivoted off their network into the utility network and hacked the server at my customer's network, and that's the reason they showed up with the free upgrade. And so that got me thinking, with all of these different vendors that are integrated together and have these open trust relationships in these head-ins, central offices, data centers, what is the likelihood that a vendor gets popped, they're pivoted off of, and they go into, say, another one of their customer networks, and then the adversary is able to pivot off and exploit the trust relationships that are inherently existing and go back into other vendor networks and just totally just daisy chain and pop numerous customers, numerous vendors by way of these trust relationships that exist, because when you get into these networks, they're flat, there's no segmentation. I'm talking about flat layer 2 networks. There's no private VLANs. There's no VLAN ACLs. If they're routed, they're not doing ACLs between the routed VLANs. If you get in, you have access. This goes back, I'm wondering about the Target attack where the HVAC vendor got hacked and then Target got hacked. If Target was letting their HVAC vendor come in remotely, the question in my mind is how many other vendors came into that network and was possibly there hairpin turns happening where they were able to shoot back into other vendor networks. I don't know. I wonder about these things. So here's another network scenario. The telco put in a new transport network where they're running numerous services across their core backbone. and the vendor put in a Linux box, multi-homed, totally bypassed their firewall infrastructure. In this case, the telco had a very large investment in firewall, VPN, IDS security, but politics being what they were, the transport network part of the organization was able to get their network installed so that their vendor could bypass the security infrastructure that was in place. There wasn't a corporate policy driven down about how vendors were going to come into the network and be managed. So they were able to bypass the firewall with their multi-home Linux box with a wide open SSH service so that anybody could find it could brute force it. And they did, and they hacked it. No account lockout in any of these cases, by the way. And the hackers got into the network and were able to control the whole transport network. Luckily for the telco, they didn't know what they had gotten into, but they got into the system that could have took out services for the whole region because it was the core transport network. It wasn't the access, wasn't a particular service. It was the core backbone network management system. Everything was dependent on that part of the network. But thankfully, a bank in Europe notified them that the attack had happened, and so then we got brought in to help mitigate it. So recommendations from a guy who goes out and builds telco networks and then figures out how to break into them. Here's some recommendations I have. Typically the networks are managed in band where there's one physical network and there's multiple services running across that physical network, including the management plane. I highly encourage you to go and take the OSI model and work your way from top to bottom of locking down the control plane, management plane, and data plane of every layer of the OSI model. Make sure all the different services are locked down and secure. And if you're using one of these new higher end networks, especially if you're in the critical infrastructure world, you should have the software services that will support this. Use virtual routing forwarding instances that we utilize in MPLS, multi-protocol label switching, so that you can carve up your routing table so that normally in your routing table you have the one global routing table, but when you start taking advantage of VRFs in MPLS, you can logically carve up your IP routing table so that there's a routing table for all the different services that you define. And what I want to see is that the management network is in its own VRF and its own MPLS VPN, so that if someone gets into the data network, into the data plane, they're not able to pivot and get over into the management network and have direct influence over your network infrastructure by way of the management plane. Because when I come after, if your organization hires me to come out to test your network, I'm going after this management network. I don't care how much money you spend on security. If I can find a way to touch that management plane, everything is lost. And at the same time, in that MPLS or the VRF for your management network, I'd encourage you to have a separate non-attributable VPN just for remote access to the management network, so that no one is able to go and directly target that from the internet. Have that totally isolated. I'm very, very paranoid about the management network being secure, and for the love. I mean, our static passwords are toast. They're worthless. We've got to go to two-factor authentication for these networks, for the network devices and for all the network management servers. If that trust relationship can be exploited, it's all over with. If you have budget, I mean, especially with these critical infrastructure networks, it is a rounding error to go in and put in a secure managed infrastructure. I mean, we spend all this money on all this critical infrastructure and we neglect the management operation of it. What I'd like to see is an out-of-band network put in place that is dedicated for managing this network infrastructure, so that and again, use an unattributable remote access with two-factor authentication and monitor everything. The routers and the servers, switches that are deployed today, they all have an out-of-band network connection available. Why not use it and build out an out-of-band network infrastructure and have that totally secure, so that if an adversary breaks in, they pop us with some advanced malware, they can't easily pivot over into the network management infrastructure and take over complete control influence over the network. Because this is where I see the adversaries are really skilled are going for. Everybody's looking at the endpoint devices, and while everybody's chasing the endpoint problem, The adversary's pivoted into the network infrastructure and is laughing the whole time. And as soon as you go in and clean up the endpoint devices, they're right back in because they're probably inside the network infrastructure. And in these critical infrastructure networks, whether they're the telcos, the SCADA, smart grid, et cetera, one thing is prevalent that's got to be stopped. We put in all this new network infrastructure, whether it's Juniper, Cisco, pick your Kool-Aid for a new managed network device. The layer 2 problems, old school layer 2 problems are prevalent. We should have been past this years ago, but it shouldn't be that someone can get physical access somewhere in the network and start running old school stuff like arc poison. I hate to say this, but if somebody can get physical access, they can own the network very easily. They don't need a day zero. They don't need any APT. All they have to do is pull up something cheesy like Cain and Abel, and they can start popping the network. And then you have the first hop redundancy protocols where you may have routers running in parallel redundant so that if one router fails, another one picks up automatically. And you might be running the VRP because it's anything but Cisco shop, or you may be running HSRP because it is a Cisco shop. Wherever we see those, if authentication is there, it's clear text, even though MD5 is an option. There's typically no authentication, and if there is authentication, the password is, if you got access where you can exploit it, you can see it in your packet sniffer, that the password is typically Cisco, because that's what they did in class. Just sitting there passing on the wire so that you can go in and do man-in-the-middle attacks against the first hop redundancy protocol. This stuff needs to be cleaned up, and one way is that, and this is prevalent also in the enterprise networks, and how I recommend it to attack this so that everyone can save face on the network team is maybe going to attack it as a BYLD problem and use something like Cisco Identity Services Engine, where you can start with the wireless network and work your way in, and to work your way into the physical network, into your router, your switches, and clean up the port security on these networks and clean this mess up, because it is prevailing everywhere. Bottom line recommendation is everybody's talking about whitelisting applications, but why not go and whitelist the network traffic? Let's figure out what the trust relationship should be on our network. Who should talk to who, when, where, and how much? I mean, let's lock down those trust relationships of the servers and the network peripherals. Lock down that management plane, and anything that tries to violate that trust relationship is what we should be monitoring, because we're overwhelmed with all the noise in our logs. If you're trying to do really good logging, in many cases, they put the infrastructure in place for compliance, for audits, and then they don't pay much attention to it after it's put in place because they're overwhelmed with all the noise. Well, if we just went in and whitelisted what should be happening between IPs, ports, and services, and had that whitelisted, and then monitor what violates that trust relationship, we would catch a lot of the problems that are happening in the networks. That is the information I had to share with you today. Is there any questions?
Just add to your list, I'd add user self-provisioning portals connected to the internet and connected into the control system, whatever it is. Control system probably is running some old crappy OS, is not patched, and database definitely is not patched. And the in-band management probably is also running on old proprietary cards that have some old Linux stack from about 10 years ago.
That's right. Old unpatched SSH services, probably running an old Solaris 2.6 with some old Oracle with all the defaults. Yeah, that's it. Yeah, you know what I'm talking about. You've seen it. Any more questions? Anyone but Jason? Anyone?
Different physical layer, access layers, transport layers because of the application. What are your views on the new threats coming with SDN, with software-defined networking?
I've not worked with SDN as of yet, but I'm very interested in what's going to develop in that domain. I haven't worked with an SDN network yet. I'm reading about it, studying it, but none of my customers have rolled out SDN yet. It's all waiting to see what's going to happen. My customers are trying to figure out whether they're going to go and do like the Cisco ACI or they're going to go with the open source route. I'm hoping in the future to be able to come back and brief on that. I'm very interested in how that's all going to work and what that's going to bring into play. What I expect to see initially with SDN is to be put out at the edge of the network, at the access layer, where there's a lot of synergy to be, there's a lot of capabilities, problems to be solved with east-west traffic in the telco networks, access layer. So, it's going to be interesting. But I have no personal experience with it to speak to. Jason?
I hate to bring this up, but Win Schwartar said that you're going to be talking about solar flares. I did not hear solar flares in that presentation. And so what is your comment on the possibility of solar flares infecting the network and stuff and how that would be a bad thing? Because I was promised solar flares.
I take no responsibility for anything that Win said before I got up here. I know nothing about solar flares except for what I learned during Win's presentation. So maybe next time I'll have a presentation on solar flare effects on networks. Anyone else? I appreciate y'all letting me come and speak today. Thank y'all.